Hi, everybody. Welcome to Chapter 7. Now that we are in Chapter 7 and in the second semester, we're going to start doing things with exponents. And so Section 7.1 is the beginning of looking at exponents, looking at variables with exponents, and what do you do with them. So first of all, an exponent is the little number. We've got a base to a power. The power is the exponent. For example, you might have something like 5 to the third power. So the base is 5, the power is 3. You multiply the base by itself the power number of times. So in this particular example that I wrote down, 5 to the third power, that means that we write out that base of 5 3 times, and we multiply them together. If you're going to your calculator, I think that's going to be 125. So if I've got an x to the 5th power, we know that there are 5 x's, and we're going to multiply all of them. Isn't writing x to the 5th a lot easier, quicker, and less work than writing x to the 5, or writing out all 5 x's? So real quick, a monomial is any number, variable, or multiplying a number in a variable, like a 5x to the 3rd power, or a x to the 6th power, or an ab cubed. Those are all monomials. Notice it says nothing about dividing. And constants are real numbers. I use the word monomials in there, but really the important part is they are real numbers. So constants are numbers. Monomials have variables. So constant might be 8 or -3 or 17 or something like that. So they are the numbers. Monomials have the variables. So determine if these guys are monomials. Letter A, it says x plus y. It's a yes or no question. Did we say anything about adding when we defined a monomial? So that's a big no because there is addition in it. Right down below, -5, is that a monomial? Well, in my technical definition, right, I said that a monomial that is a real number is a constant. So any plain old numbers are yeses. Those are monomials. Letter C is kind of a tricky one. We've got an ABC over 5, and I know there's a fraction in there. But remember when we were graphing equations or graphing lines and things like that, we might have something like, instead of keeping it with the variables in the fraction, we would take the fraction and put the variables next to it. Well, if I have 1/5 times A times B times C, that's a monomial. It's a product of numbers and variables. So the only thing we're allowed to do to get a yes for a monomial is to multiply. No adding, no subtracting, and no dividing. So D, hopefully everybody's going to tell me that's a yes. How about part E, or letter E? X squared over y. This over, right, means division. And again, did we say anything about dividing in our definition of a monomial? That would be a big negative. And I'm guessing that everybody knows that F is a big no as well, because even though we've got a 5 and an x, the x is in the bottom of the denominator, or bottom of the fraction. So that would be not a monomial. Right. Now that we've talked about this, just recognize them. Now comes the fun part. So we did a little bit of practice in class, the product of powers, and hopefully you have done some figuring out with this. When you have a product of powers, you keep the base and add the exponents. So in other words, if you've got x to the 3rd times x to the 4th, we could write that out. That first one tells us we've got 3 x's multiplied. The second one says we've got 4 x's multiplied. So that means how many x's do I have? X to the 7th power. Power of a power is something like x to the 3rd squared. So what do you do when you've got x to the third squared? Well, we could say that's like x to the third times x to the third, right? And then we could say, move that up a little, then we could say that that's like 3x's from the first, 3x's from the second part. So what will our final answer be? X to the sixth. So our shortcut, if you don't want to write it all out, is to keep the base of x, multiply the exponents, in this case 3 times 2. And power of a product. So something like 3x cubed, and then we're going to go ahead and square that. So we're really going to do the same thing that we did power of a power, only power of a product, it's almost like we have, well, let's do this way first. So this 2 tells us that I've got 3x cubed times 3x cubed, which means that I've got 3 times x times x times x. And then I've got another 3 times x times x times x. So I'm going to ask you, what do you get when you multiply the 3's? How many x's do you get when you multiply them together? Simpler way to write it would be x to the what power? 6. So 9x to the 6th. I almost look at it as distributive property. You're going to distribute the exponents to each base. So 3 is a base inside those parentheses, so I have to do 3 to the second power, not 6. And x cubed is another base within that within that parenthesis, so I have to do x to the third squared. Write them out, it will always work. So, kind of the last wordy part, and then we can do some examples. Here's what it means to simplify an expression. Whenever you've got monomials and I say simplify it, here's what you need to look for and take care of. Make sure that every base only shows up once. You can't have an x at the beginning and an x at the end. You put them together and make x squared. Make sure there are no powers of powers. So in other words, there are no exponents. Hold on one second. So we've got no exponents when you're done with the problem. We're also going to make sure you simplify any fractions. Nobody is going to tell me that 3/9 is the final answer. You're going to tell me that that's 1/3. We won't talk about fractions for a little bit, maybe till the next section. And you're going to make sure that all of your exponents are positive. An example of that would be like x to the -2. We won't get to that for another couple sections as well. But those are the 4 rules. You don't have to memorize those because you're just going to know to look for those guys. All right, so let's do a couple practice problems. We don't need to do a lot because we're going to do some in class, and we've already done some in class. But let's just look at what these guys are. So number 1, we've got a 5x to the 4th times an x squared. So that means if you want to write it out, I've got 4 x's from the first parenthesis. I've got 2 x's from the second parenthesis. You may be able to use a shortcut and know that it's 5x to the 4th power. Oh, nope. Get it right. 5x to the 6th power, right? I've got 4 over here, and I've got 2 over here. The 5 didn't have anything to multiply with. So let's just jump down to letter 3, or number 3. So we've got r to the 4th times a -12r to the 3rd. So if you like to write it out the long way, I've got r to the 4th. Second parenthesis, I've got -12 times r. And then I'm going to simplify that down. Notice I've still got parentheses in here, and I've got more than one r, so I need to take care of that. The -12 has nothing to multiply with. The r's we can simplify and write that as r to the 7th power. 1, 2, 3, 4, 5, 6, and 7. Let's skip 2 and 4 for now. Let's look at, I'm going to skip 5. 5 is a bit busy. Number 7, though, is a good one. I've got ab squared and an ab squared. Those are not the same thing, right? It's all about where those parentheses are. So look first at the ab in parentheses that is to the second power. That means that I've got an AB written 2 times. If you ever get stuck in these problems, write them out. If we look at the second one, AB squared, there's nothing on the outside. We don't have to write that parenthesis more than once. So all we've got is an A times a B times a B. So when I ask you to simplify that, I'm going to ask you to write an answer as A to a power, B to a power. What's going to be the power on the A? How many A's do we have? What's going to be the power on the B? How many B's do we have in this problem? My final answer for this will be A to the third, B to the fourth. So we're going to do some more practicing with these problems and add some others in as we go to section 7.2. So here's what I would like to know for the lesson summary. Please make sure you do this. I really want to know, what do you think is easier? Writing out all of them and seeing how they combine, or using those shortcuts where we add the exponents or other things like that, multiply? So tell me what you think is easier, and of course, why? And one problem for you to do, take that 3x squared and raise it to the third power. So no parentheses, you're going to have a number times x to a power. Write it out, use shortcuts, whatever you think is easier. And remember, go back, this is the first section of chapter 1 or chapter 7. So this is going to be huge, everything's going to build. So go back and rewatch if you need to, or after we talk about this in class, before a quiz maybe, come back and watch, because that way you'll know what you're doing. It'll reinforce what we've already talked about. That is it for section 7.1. We'll see you guys next time.